going to be a great mystery, Finley. You'll figure it out. All right, so we're on page 36 of our notes. And we are going to do the exponent review. Exponents are important because logarithms and exponents are inverses of each other. So if you understand how to do exponents, then logarithms are going to be much easier for you. Okay? So our calculators are put away. Here, you should be like joyful and bouncing. You're coming to math class. Skip, exactly. So we're on page 36 of our notes, and we're looking at problem number 10. And we're going to start simplifying. So, 2 to the negative third, what's it mean? You guys know this, I'm not teaching anything. You know it's 1 over 2 cubed. So that's going to be 1/8. What about 8 to the negative 2/3? 8 to the negative 2/3. Well, using Chris's idea, won't that be 1 over 8 to the 2/3? What does 8 to the 2/3 mean?
The cube root of 64.
Cube root of 8 squared, exactly. Now, Lewis, you can think about it like this, which is how you thought about it. Sometimes it's easier to think about it like this, depending on the size of the number. So the cube root of 8 is 2, and 2 squared is 4. 2 squared is 4. And then 8 squared is 64. That was on video, by the way. 8 squared is 64, and the cube root of 64 is 4. So it works either way, right? But if this number is kind of big, it's usually easier to take the root first and then you take the power. So, for those of you that may have forgotten, Lewis got this exactly right. When you have a fractional exponent, the denominator tells you the root that you are taking, we call it the index, and the numerator tells you the power. All right, 16 to the 3/4.
4 to root.
4 through the 16 cube. Well, what's the 4 through the 16?
2.
2 cube.
8.
8. So this is one where you see this how much easier it is, yeah. All right, 5 to the 1/2 times 5 to the 3/2. We know that when bases are the same, and this number is called the base of the exponent, we know that when the bases are the same, we can combine the exponents. So when we are multiplying 5 to a power times 5 to another power, what am I going to do with these exponents?
Add them.
So this is going to become 5 to the 4/2, or 5 squared. Now, somebody is going to take a problem like this, 5 to the 1/2 times 5 to the 3/2. And somebody's going to say that's 25 squared. The bases never get multiplied, guys. The exponents get added, and that's it. When you have x squared times x cubed, isn't that just x to the 5th? You don't change the base. So the fact that it's a number, this is wrong. The fact that it's a number doesn't change the rule. The base stays the same, and you add the exponents, or subtract, whatever you're doing to the exponents. The base doesn't get changed. All right, how about -3 to the -4? Well, that'll be 1 over -3 to the 4th. Remember, when you do the whole 1 over thing, all that does is change the sign on the exponent. So now, what's -3 to the 4th? 1 over 81. Now, negative 3 to the negative 4. Be careful with this one. The exponent is attached to what?
The 3.
Just the 3. So it's, you need to think of it like that. Think of it like that. The exponent is only attached to what it is immediately attached to. So this is going to be negative 1 over 3 to the 4th. Would you agree with that? Which makes our final answer then negative 1 over 81. Oh, we got pages of this, folks. We have a lot. That's pretty good. All right, tell me what you think about this guy.
Do the ones in the parentheses first.
PEMDAS doesn't change. What does PEMDAS tell me to do?
Parentheses.
Parentheses first. So I gotta deal with what's in the parentheses first. So what's this? 1 over 4, 2 squared? Plus, what's this?
1/3.
1/3. I'm not done in the parentheses, now I have to add those. So I'll get a common denominator. So this will be 3/12, and that will be 4/12. So when I add them, I get 7/12 to the negative first.
12 over 7.
Cindy, are you okay? Yeah. You do it all one way around. Right? So what do we do here? What do we do with that? 7/12
Is
to the
it
negative first.
12, 7.
Flips the whole thing. Because you, just remember it flips the whole thing. But what's happening is, this is 7 to the negative first over 12 to the negative first. So that's gonna come to the bottom and that's gonna come to the top. So the answer is 12/7. Do we ever distribute an exponent? Not if there's a plus or a minus involved. If it's multiplication, then you can, but not if there's a plus or a minus. You cannot distribute the exponent. You have to work inside first. Perfect. All right, number 8. Not sure what that one's doing in there, except maybe just to remind you of that. What's x plus y squared?
X squared plus 2xy.
X squared plus 2xy plus y squared. In other words, we FOIL. You can't distribute the exponent. It doesn't work that way. How about number 9?
It's 1.
Why is it 1?
Anything to the 0
Because
is 1.
anything to the 0 power is 1. That isn't just some random made up rule, guys. Think about this for a second. Would you agree that x to the 5th over x to the 5th is 1? Would you agree with that? But according to the rules of exponents, if the bases are the same and I'm dividing, what do I do with my exponents? Subtract. So wouldn't that be x 5 minus 5? Isn't that x to the 0? But you already told me that was equal to 1, so x to the 0 is 1. Because it represents a top and a bottom that are the same. All right, what about number 10?
Distribute the exponent.
Well, you can do this, whatever kind of way works for you. When I see that negative exponent on a fraction, first thing I want to do is turn it over. That's me, that's what I want to do. And then I'll square everything. Now, you guys are really smart, so you can probably maybe do that all at once. I do it in 2 steps. I take care of the negative first, flip it over, and then take everything to the second power. Does that make sense to you? for the first fraction. Now I'm gonna do the same thing with this guy. So y cubed over x to the sixth. Now I'm multiplying. This is a multiplication problem. So is there some canceling maybe I might want to do? So those are gone, and that would leave with 4 here. Those are gone, and that would leave with 1 here. So what am I left with on the top?
1.
Yep, just my little 1. And on the bottom, I have x to the 4th y, or yx to the 4th. All right. You probably don't need me at all for the next 3. So could I have a volunteer maybe to come up and do, this is 11, and another volunteer to do 12, and another volunteer to do 13. Do we have some volunteers? Okay, if no more volunteers, then you just have to listen to me.
I can do it.
Thank you.
I'll do it.
Anything except listening to Mrs. Ward.
I'll do.
Oliver's gonna do it. Wounded warrior there.
Alright, I'm gonna explain it.
Hey, listen, Oliver's gonna explain that second one there to you.
It's like a cubed root because it's to the 1/3. Then just do it.
Is that looking okay to everybody? Good job, Oliver. Couple more years, you can have my job. Okay, wanna explain what you did there, Cindy? You did, I think it looks great. Wanna explain it, Carl?
Well, this is, 2x, the square root of 2x cubed, and that's, since that's negative, I didn't really look at it like that, I just know if it's powers and you're multiplying, you add it.
That's what you
So,
do.
yeah,
That's what you do. Yeah, don't overthink it. Now, certainly what you said originally was right, Sydney,
Yeah.
but this is a multiplication problem. They're both x's. We're gonna add those exponents and we get 1. 2 times 4 is 8. The answer is 8x. Perfect. This one, this is a multiplication. So you are gonna take 2 to the 3rd and x to the negative 1/3 to the 3rd. Now, this is not an addition situation. X times x is an addition of exponents. What do I do with these exponents?
Multiply.
Multiply. So your answer is 8 over x. Thank you, volunteers. All right, here we go, next one. By the way, we're gonna have a quiz over this. Yeah, so you gotta make sure you know these rules. All right, so what are we gonna do with this guy? They are all x's, which is the best possible situation. They're all x's, so we'll get a common denominator. 6 and 5, 30. So x to the 10 30s, x to the 5 30s, and x to the 6 30s. Now, you got all these x's, so your answer is going to be x to the something. What will you do with the 10 and the 5? Add. And what will you do with the 6? So what is that? 9 30s? And we will reduce that, of course, to get 3 10s. Done.
Do you need to put it as the 10th root of x to the
Nope.
cube?
General rule of thumb, Oliver, is that unless you're told otherwise in the directions, whatever form the problem is written in is the form that you answer. So if it starts out as a radical, then we're going to answer it as a radical. If it starts out as fractions, we're going to answer it as fractions. Okay, what about this next one? What's the square root of x to the 4th over x to the 8th? Well, first of all, what's x to the 4th over x to the 8th? 1 over x to the 4th. And what's the square root of that?
1 over x squared.
1 over x squared. You people are amazing. 16 is so easy, we're not even gonna write it down. 16 is a to the 4th, b to the 10th. Is that settling in with everybody? 17 is the same problem. It's going to be 3 to the 1st times 5 to the 1st, which is going to be 15. 15. Four ninths to the 3 halves. I don't know about you, but my brain does not really comprehend fractional exponents. As I was writing this down, I was immediately thinking the square root of 4 ninths cubed. Were you thinking that way? The square root, this means the square root cubed. So what's the square root of 4 ninths?
2/3.
2 over 3. And then I'm gonna cube it, so I'm gonna get
27.
8 over 27. How about this one? What's gonna happen with this guy? What am I gonna do with the exponent?
Multiply.
Multiplying. And what do I get when I'm multiplying?
1/3.
1/3. And 8 to the 1/3 means the cube root of 8, so the answer is 2. Okay, Oliver?
Did you say that for 18, the one that we just did, the square root of 4 ninths could be negative 2/3?
You could. Generally speaking, we're doing principal values, which are positives. So if there is an exponent, we normally think of a fractional exponent, we normally think of that as being principal values, which are the positives.
Okay.
But yeah, I mean, absolutely, the square root of something could be negative. All right, number 20.
Got an equal base.
Would you agree that another way of writing this would be 8 times 2 to the 3 halves? Is that the same thing?
No.
I think it is.
Multiply,
Oh, yeah.
same thing. And 8 times 2 is
16.
So it might be easier to do the problem as the square root of 16 cubic, which will be 64. Thank you, Louis. Now, could I do the individual pieces? I could. The problem is the square root of 8 something I know? Square root of 8, it's something, it's radical, right? And so is this one. And when I multiplied those two radicals together, I could simplify and eventually come out with 64. But since these exponents are the same, it's easier, I think, to go ahead and combine them. Tess?
So you don't add them?
Add the exponents? Tess, are the bases the same?
So the bases are.
No. Remember, your exponent rules only apply when the bases are the same. So you are never going to add exponents unless they have the same base. Right? Yes, not at me. Yes, that's correct. This is where you are right. All right, let's quickly go through number 6 because these guys are a little bit different. Or not 6, B. These guys are a little bit different. These are equations now. So we're going to use what we know about equations and exponents to solve these. What's your thought on this guy?
Square root of 4 minus x equals 8.
Could you think of this as the square root of 4 minus x? Could you do that? And then what would you do if you had to solve that?
Square both sides.
Square both sides. And then it ends up looking like what? Negative 60? Is that what you got? Let's go back and check that, because remember, when you do this, you square both sides, you introduce the possibility of extraneous roots. So I think we're fine, but let's check it. Negative 60, what's 4 minus negative 60? 64 to the 1/2 power is indeed 8, right? Now, what you did was absolutely fine. I want to show you something though. The problem, my job was to solve for x. The problem was it's inside this parentheses to a power. So another strategy we might employ is squaring both sides right here. Because what happens when I take something to the 1/2 to the second? What do those exponents do? Cancel each other out. So you don't have to change it to a radical, but you certainly can, if that works out for you. All right, how about the next one? This guy's a doozy. This is a doozy. First of all, what's happening here? I'm raising this to another power. So what am I going to do to those exponents?
Add them.
I'm going to
Multiply them. Multiply them.
multiply them, right? I'm going to multiply them. So this is 5 to the x squared over 5 to the 2x, and that equals 5 cubed. That is the key to the problem, because remember what I was yelling at Tess about? The bases have got to be the same. If you're going to do stuff, the bases have to be the same.
So it doesn't apply.
Now,
Why wouldn't you square the 5?
Yeah.
Do the denominator. You just
Square
times
what
by the
five?
x.
On the denominator, why would it be 125x squared?
down here,
Up top, it's in the parentheses. On the denominator, why wouldn't it be 125 x squared? Like, why does the 2 only apply to the x?
25.
Oh, no, 25 I mean.
Okay, so I want you just to stop and think about it. Okay, listen. If we have m to the second cubed,
Oh yeah, she's gonna be the 6.
what is the answer to that question?
M to the 6.
M to the sixth. Did the base change? No. Remember, what this means is 5 to the x times 5 to the x. That's what this means. What does my exponent rule tell me to do? Add my exponents, but I don't change the base. If this were m to the x times m to the x, it would be m to the 2x. You don't change your base. When you do operations with exponents, you don't change the base. So if you're adding exponents, your base has to match, and it ain't gonna change. When you're in doubt, ask yourself, and the issue is always when there's numbers involved, ask yourself, what would I do if that were a letter? And then do the same thing. Now, I want you to look right here. This is a division problem. So what's that gonna become?
5 to the x squared minus 2x.
To the x squared minus 2x? So does it make sense to you?
Yeah.
That I didn't cancel those, right? I kept the 5. Same thing with multiplication, it stays 5.
That's x squared equals 3.
And that equals 5 cubed.
Can you eliminate?
Now think about that for a second. If 5 to a power equals 5 to another power, what has to be the case? The powers have to be equal. So now I have an equation that says x squared minus 2x equals 3. Which I can, I'll get it set equal to 0. Factor. So this problem's gonna have 2 answers. What are the 2 answers?
3 and -1.
3 and -1. Alright, there's a lot going on in that problem, so just sit for a second, digest it. There's a lot going on. What if that number hadn't been 125? What if that number would have been, I don't know, 120? We would have needed logarithms. That's what we use logarithms for. When the bases don't match, when you can't make the bases match, then you're gonna need logarithms. It's coming. It's coming. All right, couple more, and then we'll move on. X to the -1/2 equals 4. Let's raise both sides, whoops. Let's raise both sides to what power? -2, very good. Because what do I do with these exponents? Multiply them, and when I multiply them, they'll cancel and leave me with x, which is what I want. So x equals 4 to the -2nd, which is 1/16. There are always other ways to do the problem, so if you're thinking along different lines, as long as you're getting 1/16 as the answer, that is fine. Easy one. 3 to the 2x equals 3 to the 12.
X equals 6.
2x equals 12. And x equals 6. Again, if this had been 3 to the 2x equals 5 to the 12, then I would have logged both sides and done my logarithm things. Finally, x to the 2/3 equals 9. we're gonna raise both sides to the
3/2.
So x, right, this all cancels, so x equals 9 to the 3/2, which is the square root of 9 cubed, which is 27. All right, is everybody okay with that? Everybody, that exponent review, all good on? All right, we're gonna come back and, oh, wait a minute, maybe we should do C. Which two in each set are equivalent? Okay, so look them over. You got 3 different equations. And you're trying to figure out which ones are the same. So in number 1, which of those equations do you think are the same? A and C. Let's see if you are right. So there's A. Not really much I can do with that. But C, 9 is 3 squared, right? So if I change that 9 to a 3 squared, then I have a double exponent. And what will I do with that double exponent? Multiply. So I think you're right. I think you are exactly right. A and C were the same. All right, how about number 2? What do you think about number 2? A and B, you think? Okay, so there's A, and then here's B.
I don't think it can be A and B. You have to do the what's in the
Okay,
parentheses
so
first.
I went ahead and put an exponent on this 2, this is B. I went ahead and put an exponent on this 2. So now I'm multiplying these together. So what do I do when I multiply like bases? I add the exponents. So I'm gonna have 2. And then when I add these exponents, I have 1 plus 3x minus 2, which is 3x minus 1. And that, oh, wait, that didn't match the first one, that matches the last one. So B and C are the match there. Got it? Okay, so what's gonna happen next time that we are together is we're going to have an exponent quiz. Now, I have a few more practice problems that I will post in Schoology. If you want to practice them, fine. If not, fine. But the next time we come, we're going to have a quiz over problems like we just did. Everybody clear on that? Okay. Now, let's get back to our old notes now then. Actually, you know what, I think what I might do is, I might go, I have this ready, instead of putting it in Schoology, would you like to have a hard copy of it?
Yeah.
Alright, I think I'll go run this off, because I'm gonna set you loose on this page of notes, in the old notes, 3.1.
I think it's on the back side of our, it's on the back side of our,
Old notes, yeah. What is?
we're just gonna print it off
I'm gonna print out paper, yeah. Well, you're working on this. So here's what you're gonna be working on. It says, which are exponential functions? For those that are, give the initial value in the base. For those that aren't, why not? So I want you to look up above at the definition of an exponential function. The exponential function is one of your BFFs. What did that equation look like? There are lots of exponential functions, but what did the one that's a BFF, what was it? y equals e to the x.
Okay.
So the key there is, kids, in an exponential, x is the exponent. So it's not x squared, it's 2 to the x. That's what an exponential is. So read that, look at the little definitions about a and b and all that stuff, and see if you can figure out number 1. All right? If you get that done before I get back, try 2. 2 is easy, just plug and check. I'll be right back.
So what does B actually represent? Like a foil? It's like a real number. Okay. Like what is that though? You know what number it is? Like
Some non-terminating, non-repeating.
so it's like pi, but a different version.
We talked about it.
I briefly talked about it. Yeah.
Mr. 94 with the answers.
It's pumpkin bread's gonna miss us.
No, I did that, but I was almost like a bunch of wall bagger that way.
Yeah.
We were, I was like, that was okay.
Oh, yeah. Yep. Give me my recommendation. I got my top.
You got a 94.6.
I'm gonna challenge my question. I already know you.
Random variance.
Okay.
Okay, the practice problems are coming around. So what I will do is I'll look through those and post them in Schoology, the answers, okay? And then whatever. Look at it or don't look at it, I don't care. So what do you decide? Is A exponential? Yes. What is the initial value? 1. Very good. Because the initial value, an exponential looks like this. And this is the initial value. So in your problem, you don't see a number there, so it's a 1, right? So your initial value is 1 and your base is perfect. Is B exponential? No. No. Exponential means the exponent is x. This is a power function. You were in the last year, some of you did. C, exponential? Yes. Initial value is -2, and the base is 1.5. How about D?
How's the initial value negative 2?
The initial value is 7. I'm looking at D, letter D. The initial value is 7. And what is my base? Be very careful. 1/2. Why is the base 1/2? Because it's a negative exponent, right? So it's 2 to the negative first to the x. So whatever you're raising to the x is your base. So your base is 1/2. Finley, raise your hand up.
I figured it out.
So B isn't exponential because it's not 6 times x to the -4.
No, if you're exponential, your exponent is the variable.
Oh,
Look
yes,
at the problem.
yes, yes.
The exponent is not the variable, right? All right, E. That is nothing. I don't even know what that is. It doesn't even have an x in it, right? That's just a number, whatever that, you can type that in on your calculator. So E is not exponential. All right, f of x is 2 to the x. So what's f of 4? 16. Be confident, Lewis, you're right. What's f of 0? 1. What's f of negative 3?
1/8.
1/8. What's f of 1/2? Square root of 2. What's f of negative 1/2?
Square root of 4.
1/2.
Not 1/2.
Square root of
Negative
1/2.
square root of 2.
Square root of 1/2.
So we have 2 to the negative 1/2. So that's 1 over 2 to the 1/2, which is 1 over the square root of 2, which is the square root of 2 over 2, when you rationalize it. Alright. 2 to the negative 3/2. So 1 over 2 to the 3/2, which is 1 over the square root of 8, 2 cubes. Could I multiply top and bottom by square root of 2 and get the square root of 2 over 4? Yes, because what's my objective? Multiply by whatever it takes to get rid of the radical. And if I have an 8 down there, won't 2 take care of it? Yes. Now, if you multiply, you took, let's say you had this, 1 over the square root of 8. And you decided you were gonna multiply by the square root of 8. That is perfectly okay. But look what it leaves you with.
You can simplify.
So 2 root 2 over 8, which reduces to root 2 over 4. So it's easier just to do it that way, but it'll work either way. Alright, did everybody get your practice papers? Everybody got one? Alright, I'll work on those and get back to school and get something. Alright. Number 3, we gotta get through a couple more here. Oops, we gotta get through a couple more here and then we'll be done. So we're gonna get through 3A and Z. And then I will be stellar. Okay? So here we go. 3A and B. Directions say, write the equation of the exponential function. So I would suggest you write that down. That's an exponential function. You've done linear functions, y equals mx plus b. You've done quadratic functions, cubic functions, all of those things. Now we're doing exponentials. It contains these 2 points. Now, what happens, this is my format. What happens if I just plug in this first point? If I just put 8 in for y and 0 in for x.
A equals 8.
A would equal 8. So in other words, I want you to think about this in terms of a graph for a second. Isn't the initial value, A is the initial value. Isn't the initial value the same as the y-intercept? So whatever the initial value is, that's gonna be your y-intercept. So now I have y equals 8 b to the x. Agreed? So let's now get the other point. The other point. So 1/2 equals 8 times b squared. Remember kids, the point is an x and a y. So make sure you're plugging it in for x and y. So how am I gonna solve that?
Divide by 8.
Divide by 8, which is the same as multiplying by
1/8.
1/8. So this is gonna be 1/16 equals b squared.
Square root.
And b is going to be
1/4.
1/4. So coming back to Oliver's question earlier. In exponentials, guys, the base has to be positive. The base has to be positive. In logarithms, the base has to be positive. So when we start square rooting, we are going to stick with the principal root. So what's my answer? Y equals 8 times 1/4 to the x. Am I ever gonna multiply the 8 times the 1/4? No. Never in 1,000 bazillion years. Don't do it. A and B are separate. Do not combine them. All right, try B. This is on page 35 at the very top. Try it on your own. You're doing exactly the same thing, only your points are -2/6 and 0 3/2. How many of you went straight to this? Did anybody go straight to that? Because what do we know about our initial value? It's the y-intercept. We're going to be doing some word problems with these folks. Remember, your initial value is your y-intercept. How are you solving this? Multiply by 2/3. So 6 times 2/3 is 4. Then what did you do? So 4 equals 1/b². You with me? I can't tell. So 4b² equals 1 and b² equals 1/4. So what's my base? 1/2. So what's my answer? Y equals 3/2 times 1/2 to the x. With everybody? All right. Well, we haven't finished anything, so you can't really assign anything, but feel free to look at the homework. There might be something on there you can do. At the very least, if you want, practice that practice thing and get ready for a quiz.